Good morning. I am Suganya. I am working as an assistant professor in Artificial Intelligence and Machine Learning Department in SNS College of Engineering. Now I am going to present a topic about professional ethics. In professional ethics, we are going to see what is engineering as experimentation. So, what is experimentation? Experiment means a scientific test done carefully to study what happens and to gain new knowledge. Experimentation refers to activity, process, or practice of making experiments. During the course of engineer's career, she is involved in research, experimentation, or testing of new products. During the design phase, one needs to apply various experimental procedures, which is called experimentation. In engineering, each and every stage of product or process development, experiments are conducted. In each stage, there may be uncertainty. Engineers cannot afford to delay projects until all information is received. Thus, the final outcome of an experiment could be uncertain. Therefore, one can view each engineering work, project, activity as an experiment. Engineering as social experimentation. Engineering is not an experiment solely in a lab under controlled conditions. It is an experiment on society involving lives of human beings. So, engineering can be referred as a social experimentation. It involves design, implementation, testing, redesigning, retesting, and many other activities. In the design as an interactive process include design, fabrications, assembly, physical test, simulations, prototype, pilot plan, model study, final design, manufacture and field study. In this case, the several redesigns are made upon the feedback informations on the performance or failure in the field or in the factory. Besides the test, each engineering project is modified during execution based on the periodical feedback on the progress and the lessons from the other sources. Hence, the development of a product or a project as a whole may be considered as an experiment. Engineering project versus standard experiments. Engineering projects similarities. Partial ignorance, uncertainty, continuous monitoring, learning from the past. Contrast. Experimental control, human touch, informed consent, knowledge gained. Next, similarities. Partial ignorance. The project is usually executed in partial ignorance. Uncertainties exist in the model assumed. The behavior of materials purchased is uncertain and not constant. That is certain. They may vary with the supplier's processed lot, time, and the process used in shaping the materials. Example, sheet or plate, rod or wire, forged or cast or welded. There may be variations in the grain structure and its resulting failure stress. It is not possible to collect data on all variations. In some cases, extrapolation, interpolation, assumptions of linear behavior over the range of parameters, accelerated testing, simulations, and virtual testings are restored. Uncertainties in design calculations, exact properties of raw materials used, nature of working of final product. Uncertainty. The final outcome of projects are also uncertain as in experiments. Sometimes unintended results, side effects, and unsafe operations have also occurred. Unexpected risks such as undue seepage in a storage dam, leakage of nuclear radiation from an atomic power plant, presence of precedents in food or soft drink bottle, at new irrigation canals spreading waterborne diseases, and unexpected hair dryer causing lung cancer on the user from the asbestos gasket used in the product have been reported. Uncertainties occurred in the model designs. Model used for the design calculations, exact characteristics of the materials purchased, constances of materials used for processing and fabrication, nature of the pressure the finished product will encounter. As similarities, continuous monitoring. In case of experimentation, monitoring is a continuous process that helps in progress and gaining new knowledge. Monitoring is the activity of critical observations. Performance of a product is to be monitored even during the use of product by end user. Learning from the past. Engineers normally learn from their own previous designs and infer from the analysis of operations and results, and sometimes from the reports of other engineers. It does not happen frequently. Many failures have been caused due to the following reasons: absence of interest, mere negligence, ego in not seeking information, fear of legal actions, guilty upon failure. Learning from the past. Engineers normally learn from their own prior designs and infer from the analysis of operations and results, and sometimes from the reports of other engineers. But this does not happen frequently. The absence of interest and the channels of communication, ego in not seeking information, guilty upon the failure, fear of legal actions, and mere negligence have caused many a failure. Example, the Titanic lacked a sufficient number of lifeboats. It had only 25 boats for the actual passengers of 2,227. The capacity of the ship is 3,547. In the emergent situations, all the existing lifeboats could not be launched. 40 years back, another steamship Arctic met with the same tragedy due to the same. But the lesson was learned in most of the hydraulic systems. Valve had been critical components that are least reliable. The confusions on knowing whether the valve was open or closed was the cause of 3 Mile Iceland accident in 1917. Similar malfunctioning of valves and misreading of gauges have been reported to have caused the accident elsewhere in some power plants. But we have not learned the lesson from the past. The complacency that it will not happen again and will not happen to me has led to many disasters. Engineering projects with set standard experimentations. Similarities: partial ignorance, uncertainty, continuous monitoring, learning from the past. Context: experiment control, human touch, informed consent, knowledge gained. Experimental control. In standard experiments, members of our study are selected into two groups, namely A and B, at random. Group A are given special treatment, Group B is given no treatment and is called the controlled group. They are placed in the same environment as the other group A. This process is called the experimental control. In engineering, this does not happen except what the project is confidential laboratory. This is because it is the clients or consumers who choose the product exercise in the control. It is not possible to make a random selection of participants from various groups. In engineering, through random sampling, the survey is made from among the users to assess the results of the product. Thank you.